Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 13 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 326, power of 3. Let's read the problem statement. Given an integer n, we have to return true if it is a power of 3. Otherwise we have to return false. An integer n is a power of 3 if there exists an integer x such that n is equal to 3 power x. Okay, so I'm going to solve this problem using three approaches. In first solution I will use of log 3 and time complexity, and in second solution also I'm going to use the same complexity, and the third solution I'm going to use of 1 time complexity, right? Okay, so see first example number 1, n is equal to 27, right? So I can write this n 27 as 3 power 3, right? If I write it like this, so here I have to return true. That's it. Example number 2, so n is equal to 0. I can't get n value as 0. Okay, if I uh, for any value of x, okay, if I take x as 0 only, right, in the start. So from here one thing is clear, that if my n value is less than or equal to 0, then in that case you have to simply return false, right? Because the smallest power of 3 here in place of x, if I use 0, I will get 1. Okay, so 0 is not possible, minus 1 is not possible, so here I'm returning false. Okay, so first let's solve this problem using loops and recursion. Then I will show you one shortcut, okay, in which we are going to solve this problem using just of one time complexity, right? So here first of all, here if you see n is equal to 27, right? So here if I divide this number 27 with 3, okay, so what I will get? I will get 9, right? And if I'm dividing it with the 3, I'm getting 9, right? And the remainder is 0, right? So if remainder is 0, then continuously do one more thing, divide this number 9 with 3 one more time, right? So now you are going to get here 3, and again remainder is 0. Okay, so that simply means that number can still be divisible by 3, right? Okay, now here after that I come here 3 and divide 3 with 3, I am going to get 1, and here 0 as a remainder, right? But here I'm getting 1, so I have to stop, right? So if I'm stopping here and I'm getting 1, so return true. That's it. Now if you take any other example, 28 modulus with 3, you are going to get what? You are going to get 9 here, but here you are going to get a remainder as well, right? So now stop it, right? Because we can't divide this 28 with 3, right? So this is the same thing that I'm going to use here. So here first base condition, that if your n value is less than equal to 0, then in that case you have to simply return false. Done. And here what you need to do, just make sure while your n modulus with the 3, if it is equal to 0, okay, only then just divide the number with 3. We have to return true if your n becomes equal to 1. That's it. Okay, this is done. So that's it. So here this is what we need to do. Okay, so we are only divide if perfectly divisible. Okay, so that's it, right? So here if you see here we stop now, because here if 1, okay, and then if I divide 1 with 3, so what I'm going to get? I'm going to get this as 0, right? And here I'm going to get remainder as 1, right? Okay, so I have to stop, so I come out of this. Then here I see n is equal to 1, right? So here if you see, last time the n was 1 only, right? So that's why output is going to be true, right? Now let's run it and let's see. So see, all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? And the time complexity is log base 3 n. Okay, because here n is equal to 3x we are able to form, right? And I can write it like this: x is equal to log base 3 and here n. Okay, that's it. All right, so because 27, then we search for 9, then we search for 3. Okay, like this. So it's a logarithmic time complexity. So this is using a simple this while loop. Okay, simple iteration. You can also solve it using recursion as well. Recursion, with the recursion also code is very simple. So here base condition, that if your n becomes equal to 1, right, then in that case you have to simply return true from here. And here if your n, here you can say if your n becomes less than equal to 0, right, n becomes less than equal to 0, these are the base conditions. Or the n modulus with 3, okay, if it is not equal to 0, right, then in that case you have to return false from here. Return false, right? So it must be divisible by 3, right? So here returning false, and here you have to just simply call this is power of 3, right? And this time I'm just going to pass n divided by 3 here. That's it. Okay, this is the solution for recursion approach. So let's run it again. So see, all the test cases has been accepted, and now let's submit it. So see, our solution is empty, right? And in this also, the time compressor is going to be O log base 3 n. Okay. Now let's come to the final approach in which we are going to solve this problem in just of one time complexity. Okay. So here this is a follow-up, right? Could you solve it without loops and recursion? And these are the constants, right? So here 2 power 31 minus 1. Okay. Let me just print this value. What is this 2 power 31? Okay. So let's see that. So here I can say system dot out dot print lm, and here I am going to say just give me the value, complete value of this. Okay, so here I'm just passing long, and here I'm going to use math dot power, and here 2 comma 31. Okay, let's say 2 comma 31. I'm not doing minus 1. Let's use this 2 power 31. Okay, all right. So here let's say I'm returning true. Okay, just return anything. Now if I run it, I just want to see this print statement. Okay, what is the value I'm getting here? So I'm getting something like this: 214783648. Okay, now here let's suppose if I write 3 now, next time first 3 power 0 is 1, then 3 power 1 is 3, 3 power 2 is 9, 3 power 3 is 27, 3 power 4 is 81. Okay, so now here let's say my n value is in this range only. My n value is in this range only. Okay, let's say my n value is from 1 to 90, let's say. Okay, instead of until here 2 power 31 minus 1, let's say my n value is until here. Okay, so now here if you notice one thing, this is the max number, right, which we can get 3 power 4, right? So here 81, if I divide this 81 with 1, I'm going to get the remainder as 0, right? If I divide this 81 with 3, I will get the remainder as 0, right? 3 here, 2, and here 27, completely divisible, right? Completely divisible, right? And here if I divide this 81 with 9, then also I'm going to get the remainder as 0, right? Here I'm talking about the remainder, right? Remainder. And here if I divide this 81 with 27, 81 with 27, I'm again getting the remainder as 0, right? This is 27. Okay, 27 3 81, right? 21 here, 3 4 3 2 6 7 8. Okay, so I'm getting the remainder 0, right? So this is for this range. Okay, so if I get the max number which is in 3 power x form, right, in this range, then I have to just divide that number with my n value, whatever the n value that I have given, and if the value is 0, then I have to return true, right? Okay, so same way, like here 1 to 90, let's say n is given, so I have to find the max value, and whatever the n value. Okay, if n value is 1 3 9, just take the modulus with the max number. Okay, and if it is equal to 0, then return true. So this is the same thing. So I need to find out the max number 3 power x. Okay, what is the max number that I'm going to get until here 2 power 31? Okay, so here I can do one thing. Let me just copy this. Let's check now. Let's check which one will help us. So what we need in 3 powers, right? So here 3, here also 3, let's say here also 3. Okay, and here let's say I'm passing 19, right? Let's start from 19, 20 or 21. Okay, so let's take one more, let's say 18 as well. 3 power 18. Let's see what is 3 power 18. Okay, let's see if we are crossing this value. Okay, this value, if we are crossing 2 power 31. Okay, now if I just run it, let's see what is happening here. Okay, so here this is the value of 2 power 31, right? This first one, this is the value of 2 power 31. This is the value of next one is value of 3 power 18. Okay, this is value of 3 power 19. Okay, 3 power 19, if you see, it is not crossing this value 1 1. If you see number of digits, 1 2 3 4 5 6 7 8 9 10, 1 2 3 4 5 6 7 8 9 10. Okay, 10 are there, and here it is starting from 2, it is starting from 1. Okay, but here if you see 3 power 20, it is starting from 3 and have the same number of digits, 1 2 3 4 5 6 7 8 9 10. Okay, so definitely this value 3 power 20 is crossing this, right? Crossing this value. Okay, so that simply means that this is the max value of 3 power 19. Okay, this is the max value that comes in this range. So let's use this 3 power 19. Okay, so what I'm going to do now, I'm going to use this 3 power 19. Okay, so let me remove all this. I'm going to use 3 power 19. All right, and what is the value of 3 power 19? Here one thing that we always need to make sure that n value, it should be greater than 0. Okay, this condition should be satisfied, and here what is the value of 3 power 19? 3 power 19 value is this this one, right? 3 power 19. Let's copy this. Okay, here let's copy the max value of 3 power x in this range, right? And here just take the modulus with n, okay, and it should be equal to 0, right? Here just write 0, right? Okay, so I think that's it, right? That's it. Let's run the code and see if there are code issues. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? And the time complexity for this is nothing but of 1. Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.